All right. Hey, everybody. Welcome to our next Unreal webinar. Today's topic is on creating visual effects, and I have the pleasure of having Malachi with me today to talk about that. So a couple housekeeping things. Just make sure you guys have the browser maximized for the best viewing experience. You can use Control plus and Control minus to kind of zoom in and out if the chat windows kind of overlap in the video. Of course, if you want to watch the video full screen and you don't care about the chat, you can always click on the lower right-hand corner of the little YouTube icon. So with all of that done, I want to go ahead and introduce Malachi, who will give you a quick overview of what he's going to be talking about today, and then we'll jump into it.
Hi, my name is Malachi Duncan. I'm a technical artist that formed part of the really talented art team for the Creative for All brand video for Epic. Today, I will be showing you a really quick overview of the transforming building effect that I created for the architecture sequence. I'm really happy to be able to package this up and give this back to the community because that is how I learned before I got a job here at Epic. So I really hope that you enjoy it.
Awesome. And just a couple other things. There will be a file that we're going to be including in the chat, as well as the follow-up email that comes out. That's a simplified version of the project so that you guys can follow along. Because like most of the webinars, these are going to be hitting at a very high level. It's a pretty deep topic. So Malachi will be giving you an overview of the concepts and the philosophy behind these effects we're done. And then, of course, with that project file, that simplified project file, you'll be able to kind of go back in there and have a deeper look at exactly what was done to create these effects. So with that done, let's go ahead and jump into it and check it out. Cheers, everybody.
Go. Cheers. Hello, and welcome to the Creating Visual Effects for Unreal Engine webinar. I'm your host, Malachi Duncan, and I'm a technical artist at Epic Games, and I recently worked on the Creative for All video. Here, my main task was designing the way the buildings of the city would transform and materialize, and today I'll be showing you how to make dynamic-looking rigid body effects using Unreal Engine's powerful Pivot Painter tool written by John Lindquist. By the end of this webinar, you'll be able to create an effect just like this that updates live in the viewport. The topics that we'll cover today are preparing production assets for the Pivot Painter and the best practices for asset import, an overview of a simple vertex shader, and then we'll look at how to complicate that a little bit more with a ripple effect. And finally, we'll have an overview of using a blueprint asset to create an artist-friendly asset for set dressing. Now, let's get started. Okay, so as you can see, we're in 3ds Max, and I've taken a building and I've split it into a bunch of sub-meshes, and I've set their pivots in a logical place for the rotation to happen once we're inside of Unreal. The Pivot Painter comes in two parts. It comes in a 3ds Max script, and it comes in a material function library inside of Unreal. So at least for the export process, you're going to need to be using 3ds Max. But if you're anything like me, you may have started this process in another software package like Maya or Blender. If that is the case, then what you have to do is make sure that before coming into 3ds Max, that you have taken everything out of its groups, deleted its history, and froze its transforms, and then exported and imported it into 3ds Max. And that way, you should find that if you have set pivots somewhere else, then your pivots still translate over to 3ds Max. And then finally, just for a very last sanity check, is that you should select everything and then just right click and convert to editable poly. And that is just going to make sure that everything is collapsed down. If there's any deformers on there, or if it's not an editable poly, then our script will error out once it hits that particular submesh. So this is just making sure, and it's an early flag if there are any problems that may hinder you going forward. So where can we find the Pivot Painter tool? Now, your Pivot Painter tool you can find in your Unreal Engine version. So for me, I have a folder for Unreal Engine versions in 4.25, Engines, Extras, 3ds Max scripts, and then you'll find your Pivot Painter and Pivot Painter 2. We'll be using Pivot Painter number 2. So let's run the script. We're going to go to Scripting, Run Script, and select our Pivot Painter 2, and open that guy up. Okay, so you're going to see now we've got a bunch of menus. So we've got our prep tool, we've got our render options, we've got Vertex Alpha Painter, and we've got our package tool. Now for this, we're only going to need our render tools because we've already done a lot of our prep work already. So we've already split into sub meshes, and we've already set our pivots, and we should already have set our rotation vectors, which we'll go over shortly. So our prep tools aren't really needed, and neither are our Vertex Alpha or our package model. These are more for foliage pipeline work rather than rigid body animation pipelines. So what we're going to be doing is the script is going to be taking our selection order. So we're going to create a selection inside of 3ds Max. In the order that we selected, we're going to create a new UV on a different UV channel. So it's going to be a texture coordinate anywhere between 2 and 8, depending on your art pipeline, but we're going to keep it at number 2. In that new UV coordinate, we're going to be printing out our pivot location as a texture. In the alpha, we're going to do our selection order. This is so that we can do some debugging inside of Unreal if need be. We know what order everything was selected in. Then we're going to select our rotation vector. So that is the vector that we're going to be rotating around inside of Unreal. So for this, we're going to be selecting our X vector. And for our alpha, we're going to be doing a random number between 0 and 1. This is going to help us do some randomizations inside of our shader. So just so it's clear, our rotation vectors is going to be rotating around the X over here. And we are making sure that we are doing this in local space because our script is looking at local space pivots only. So you may find that you are in view, but you need to make sure that you set your pivots in local space. Now, because our script is selection order dependent, which means that all of our textures and UVs are being created in the order that our meshes are selected. It means that on your first time setting this up, you will need to do a new mesh export because your mesh has changed. But to do a fast iterative process, you might decide that you want to change some of these rotation angles depending on how they're rotating inside of Unreal. You don't want to have to do a new export every single time, like a new mesh export every single time. So what I like to do is I like to make a selection set. So we're going to select all of this here, and in the create selection set, we're going to click in here and click entire mesh right there. And what this does is that it creates a selection set so that when we select it, it's selecting our mesh in the exact same way that we selected it when we created our selection set. And that means that on iterative work, we are just exporting textures, and we don't have to go through the mesh export process over and over again. So let's talk about the total number of submeshes. I've personally found that using submeshes around the 2000 mark is the most stable. So because of this, I've created further selection sets for the inside of the building. So if I come here and have inner, that's 512 meshes, and that's all of the floors and the struts. And then I have a different one for the exterior, which is all the facades. That's just underneath. It's coming in just underneath 2000 at 1700. And what we'll do is that we'll export these as separate meshes, but we'll play them back in unison together inside of a blueprint, so that they'll still feel like they're one cohesive mesh. This is just a workaround. So following on from that, let's process our mesh hierarchy. So we're going to come here now, and we're going to bake the textures out for there. We're going to just go to our desktop and just save them there. And then we'll just come here and do our first mesh export. We'll export selected. Export selected. I'm going to do our building outer. I've already done one of these before. And we're going to make sure we have our smoothing groups on, our tangents and binormals, and I'm going to triangulate on export because I found, especially for this pipeline, that when we do our combined mesh on our import into UE4, if we let UE4's importer handle the triangulation, it never really behaves the way it's supposed to. So I like to triangulate on export. So that's what we're doing here. Okay, well, let's jump over to Unreal Engine and we'll look at the best practices for importing our assets and our best practices for creating our first simple vertex shader. I'll see you over there. Okay, so now we're going to go over some of the import best practices. So first off, let's look at importing our mesh. So we're going to bring our mesh in. And if you're doing this for the first time, it should come in like this. And the only thing that we need to change is by coming in here, this is normally ticked off by default. Make sure that we are combining meshes because you should be exporting out 2,000 meshes that are singular, and now we just want to combine them so that they're all one. I'm going to do an import for that. This is okay. And then the next thing that we're going to do is we're going to bring in our textures. So we've got our pivot textures and we've got our X vector. Your pivot textures are EXRs and your X vectors are targets. And the only thing we're going to change about these is we're going to open them up in the text in the texture viewer. We're going to come down to their texture group, and for the EXR pivot position, we're going to change that to 16-bit data. And for our X vector, we're going to open that up and we're going to change this texture group to 8-bit data, and that's also going to change its compression setting to a vector displacement map. And now our meshes and our textures are ready to be used in our vertex shader. So we're going to go over to there and have a look at that. Okay, so we are in Unreal now and we're ready to start looking at our simple vertex shader. We are going to get more complicated with this, but I do want to show you just the bare bones of the logic, and I think that's easiest to do on some simple geometry rather than a big massive building. So what we have here is that we just have two skyscraper-esque blocks, and what I want to show here is that what we're actually doing is that we are rotating and scaling our meshes in the shader, and that is the bare bones of the effect. So although it can look a little bit complicated, as long as we kind of boil this stuff down to what it really is, it makes it a lot more easier to understand conceptually. So let's just open up the shader and have a look at what's happening. So first off, what we've got is we have our pivot position and selection order, which we're not actually utilizing right now. If you remember correctly, we put our UV coordinates in a separate UV channel, and we still need to find those. So we're creating a texture coordinate, and in our coordinate index, we are setting that to 1. Because Unreal starts at 0 and not at 1, texture coordinate of 1 will match up with 3ds Max's texture coordinate 2. And then what we're doing here is that we can actually exaggerate certain axes to make one of them grow faster than the other. So how this works is that the lower the multiplier, then the faster that axis will grow in relation to the others. So it's just if you want to make, for example, have the vertical position grow twice as fast as the horizontal positions. That's what this is for. Then when we use decode position, which is from the Pivot Painter material function library, you just type in decode position and it's right there. And we want to create a gradient between our pivot positions and a point in space. So we're giving it a free vector here, and we're going to be transforming this from local space to absolute world space, and we'll be finding the distance between the two. And then from there, we're going to be subtracting out our height, and this height is going to be the one variable that drives the whole effect. Later on, we're going to be having our ripples and our pivot painter all driven from the same value. So that this is going to become a very important value, but this is going to be driving our effect. Now we have our animation scale. Now our animation scale defines how big the animation is. It's a divider that defines how much of this height is needed to move through the animation. So the higher this number is, then the larger this height value needs to be to drive the animation. It's very difficult to explain that conceptually, but I'll be able to show you in a second when we visualize exactly what this is doing. And then we have our power, and this is basically just going to be an animation ease. And again, this will be easier to show you once we start visualizing the mask of what we're doing here. So if I just pull this out and set this to our base color. So we're in the level now and we're previewing our mask. Now the 1 values, so where the white is going to be our completely rotated meshes, so they still have all the potential to come out and be rotated back into their proper position, and they're also at their smallest scale. So at 1 they are scaled all the way down and they are invisible to us, and at 1 is when they have completely rotated into their proper rotations, and they are at their biggest value because there is no scaling being done to them because they're being multiplied by 0. And our intermediate areas here, so where we've got our gradients, this is going to be where our animation is taking place. So each point in this gradient is representing a different part of the animation. So for example, now if I was to change this to 1000, you see that we're losing some of that. We're losing some of the detail in that gradient. And if I bring that all the way down to 1, then there is no detail. So our animation will just be popping from one state to the next. It'll just be popping from off to on, or on to off, on to off. So if I bring this back up to like 2000 now, and if I change our animation easing is it's now saying, that we actually get to dark quicker than when we're 1. So it's controlling the easing in and out of dark and black. So those two conceptual things kind of shown right here. So now we're back in the material. Let's have a look and see what that mask we just looked at is driving. One thing that I didn't mention is that we needed to add a saturate, and that saturate is going to be clamping the value between 0 to 1 because we're dealing with massive height values and massive divide values. So we need to make sure that we're keeping these values between 0 and 1. So what we're going to do is that we've got our decode pivot position that hasn't been multiplied, and we're going to subtract the wall position from that. And what we're doing here is that we are we're subtracting the mesh by itself, and so that should scale it all the way down. So what we're going to do is we're going to multiply that by our mask, and it's kind of inverting it now because as we're working with an offset, when this is at 0, when the mask is at 0, we're actually not doing any scaling at all. So it's going to be all the way scaled up. And when this value is when this mask is at 1 in the white area, then it's actually scaling it all the way down. So that's what's going on here. That's how we're going to get our scaling. And then from that, we're going to do a rotate about axis, and we're going to find what axis to rotate around by getting our rotation vector from our vector texture. We're going to do a decode axis vector, the same as our decode position, but just for vectors, and that's going to go in here. And then what we're going to do is we're going to get our rotation angle. And from that, we're going to grab our random 0 to 1 from our alpha channel of our vertex texture. I'm doing a clamp here of a 0.1 and 1, because that's just because I just want to minimize having 0 values. I want everything to have a slight offset, so that's what I'm doing here. And then I'm multiplying the mask by that random value, and we're putting that into the rotation angle. And then for our pivot point, we're just grabbing that pivot point again straight from our texture. And finally, for our position, we now have a scaled position because we're scaling it here. So we're taking that scale position and we're adding back in our world position offset. So we're adding back in our world position because we're going into, because all of this stuff here that we're calculating is we're just calculating the offset. So we actually don't have the position anymore because we're subtracting from it. So by adding the world position back in, we're actually getting our position. So that's what's going on here. And then and then we add that into our scale, and that goes straight into our world position offset, and that is done. Now, one of the other things that we need to do is we now need to calculate our normals again, because we are rotating and manipulating vertices. So we also need to update their normals so that they light and shade properly. So to do that, we're just going to get our rotation axis, which is the same thing that we did up here. And we're just going to have a vertex interpolator to take that from the vertex shader to the pixel shader. And we're doing the same thing for our rotation angle. We're just taking the same rotation angle that we did for our rotate about axis, but we're just transforming it from the vertex shader to the pixel shader. And then finally, if we already had a normal map on this mesh, if we had a tileable tile texture on there, and we want that to be rotated as well, and those normals to be fixed, then what we do, we just get that normal map as an input, and we're going to transform that vector from tangent space to world space and plug that straight into the world space vertex normals here. And then that new tangent space vertex normal output is going to give us our new updated normals that account for the rotation and scaling. And that is in its simplest form. That is our vertex shader that is manipulating our geometry. Okay, so now I can show you this on something a little bit more complicated, but it's the exact same principles as we saw earlier. So here is my height. I just renamed it as anim phase inside of this blueprint, and I have two pivot painter meshes stacked on top of each other. So that's the facade and the inside meshes, and I can control them separately with the inner strut offset. So the inner strut can grow quicker or can grow behind the exterior meshes. What I did is I created a variable as well that I can control in the viewport that defines where that start position is, where that start point is. And I did that first off by creating a function. And what that function is, it's just a set vector parameter value with the name of the variable that I'm setting, which in this case is going to be pivot start position. And then I created a normal float free vector, and I ticked show 3D widget and made it public. And then I just piped that into the color value, so then that's what's getting sent. And then finally, what I did is I wrapped everything up into a material function. I brought the textures to the outside of the function so that each instance could have a different set of textures if needed. There's also a normal input to take an external normal map in. And then I could plug that into any master material that I want to become a pivot painter building. I could also add some switches so that I could switch them on and off so that it didn't affect every material instance, just the material instances that I wanted. And then inside here, just add some inputs just as they were used. I mean, that allowed me to really quickly get exactly what you see here, and just expose some random bits and pieces that I thought would be useful to have top level. But you can see it is very much the same as the small scale building which we saw. If I can change the exaggerate, I could make the vertical movements twice as slow as the horizontal movement, so that it grows out quicker than it grows up. Or I could change that around and make it twice as fast, so that it grows upwards twice as fast as it grows out. There's a huge amount of stuff that you can do just with this setup to change the way this effect looks. But saying all that, let's take a look at the ripple effect and see how we can add even more complexity on top of this. Okay, so now we're going to start looking at the ripple effect. And this is, I've just ripped it out of the main material and turned on a mask so that we can see what each layer of this ripple effect is doing. So if I play the final ripple effect, you can see that what we're getting is we're just getting a bunch of these rings coming out here. And these rings are growing over the entire building, and eventually there is another circle mask that comes in and takes it all off as it gets bigger. So let's bring this back down again, and we start to break this apart into its individual elements. So what we've got first is, so if we take these off, all of these off quickly. So the first thing that we have is we have an outer ring which contains the entire ripple effect, so none of the other ripples will ever extend will ever extend here, and it will all be contained inside the biggest ripple. And then after that we have a slightly smaller ripple that we can also offset as well, so we can say whether we can bring it closer into the larger ripple if we need to, because we've got this medium ripple offset which we've set. And that comes in just after the large ripple. These are two ripples that we can really develop into how quickly they come after each other. Finally, we have these small ripples here, and now these are meant to be more subtle than the two big ripples. These are kind of like just imagine that these two big ripples are coming through, and this is like the murmurations of and the smaller effect that these ripples have on the building. So if we just hide the bigger ripples, but we have these smaller ripples here that just pulse out for a little bit, and they have a really low strength. We can set them a bit higher if we needed to later on down the line, but they're meant to just be really subtle, just to have like a small little shimmer. So how did we build this effect? So it all starts off with the ripple center, which we can control still. So we can still come in here and change our ripple center and kind of like move this whole effect around. And that's what this is doing here. So we're getting our ripple start position and we're transforming it. And then what we do is that we have we have a master function that is creating those rings. And it's really simple. So first off, we have some inputs here. That is the ripple animation and its speed. So we're bringing in that height value that we had for our pivot position that was driving our pivot painter shader, and that's just what this is here. So then we have a multiplier afterwards, and that's giving us our speed, and that's just giving us a percentage of our animation phase. So we can offset how fast this animation is acting to the rest of the system by giving it a percentage of the animation phase. So everything's kind of offset. That's what that speed variable is giving us. Then from that, we're subtracting our phase offset, and that is just so that we can offset this effect to other effects in the medium ripple. This is how we're offsetting its position from the larger ripple. And then we're going to break it off into the inner ripple and the outer ripple. So essentially what we're doing here is that we're using max nodes just to make sure that we're always sending it positive values. We're creating a sphere mask, and we're taking our circle origin, which is the ripple start position, and we're just comparing that against the world position to create two sphere masks. However, the ripple inner has a subtraction that tells us its size. And then we're just going to subtract these two together, and that will create a nice little ring for us. And then coming from there, we just have some controls to control this ripple's contrast and to control its strength, which is what we have going on here. We do have some other outputs so that we can use them elsewhere. For example, this is the circle outer mask. So this, if we ever wanted to find out where the edge of this ring is, then we've got that here. If we also wanted to get the circle size just as a scalar parameter before it goes into the sphere mask, then we have that too. And we have the combined mask before we add all of our multipliers. So if we go back here, so then we just do the same thing twice, but as you can see, we've got this large ripple offset as well. And that ripple offset here is just making sure that this medium ripple stays inside of the large ripple. And this large ripple offset is how much this is offset from the edge of the effect. And then finally, what we're going to do, we grab our circle results and then we add them together. And then that will cover a little bit later on, because now we're going to come back up here and we're going to talk about the small ripples, because they will get added up together. So our small ripples, again, we're referencing the ripple start position. So if we call our variables the same thing, then they just become instances of each other. So whenever you update one, it will update every instance of it in the shader graph. We're transforming that position again from local to world space, and what we're going to do here for the ripples is that we're actually going to use a sine wave, because we don't want to have to keep if we're going to get a really big and bloated graph if every ripple we had to do these. So what we're going to do is that we're going to create a sine wave, and the reason why we're creating a sine wave is because when the sine wave is going to go between 1 and -1, which means that whenever we're at 1, then we're going to get a white value, and whenever we're at -1, we're going to get a dark value. So this is already, so looking from the top down, we're already going to be getting white, dark, white, dark, white, dark. So then we're already kind of getting a ripple. All we need to do is give it some coordinates, which is what we're doing here. So we're just going to get the distance to our absolute world position, and we're going to add a divide on that. And that's going to be our scale. Then again, you see we're referencing the height, which is also what has been referenced down here, and will be referenced in our pivot shader as well. We're timing that by -1 because we want it to flow in the reverse direction. Because without this, then the effect comes inwards instead of pushing outwards. So that's what that -1 is doing. And then we're just giving it a speed variable. So again, we're just giving it a percentage of this height, and then that's dictating the speed of that. And then we're going to add that to our coordinates that we've got here, and then we're going to put that into a sine wave. And then again, we're just doing some contrast, And then finally, we're going to be doing, multiplying it the same way that we're multiplying our strength down here, but we haven't covered yet. To really get a wave feel, waves tend to be really concentrated in power at their centers, and then as they push off, then they lose momentum and they lose strength. And that's basically what this function is doing, is phase dampen. So what we need is that we need to have an animation phase, so which is what we've got here, which is our height. So as this increases, we want the strength value to decrease, because that means that the longer the animation is going on, then the less powerful this strength should be. So it's just a really simple function. And what's going on in here is that we have a value to dampen over the animation. And then what we're doing is that we're taking a multiplier, because we're normally dealing with large numbers when we're using our anim phase. So we're just taking that value and timesing it by 1000. And then we're going to divide that by the animation phase. And we're going to have a multiplier on that, so that we're only taking a percentage of the animation phase. So that gives us our dampen amount. And so then as this animation phase increases in value, as the animation gets older, this value will get bigger. So the value that we are dividing our strength by will get bigger, meaning that over time that value will decrease. And we are using that on all of our sphere masks. So we're using it here and here, and also we're going to be using it here. Now, finally, the two things that we have here, we have these small ripple exclusions. So, for example, what we're doing here is that we're getting the outer edge of the largest ripple, so the furthest extent of this effect, and we're basically masking out everything that's outside of that, so that these small ripples can never extend out past the largest ripple. And then here is the fall off effect that's going to wipe over everything. So this is our duration that we've got here. So so we have this small ripple offset, which we are taking from our circle size of our large ripple. So from there we're subtracting out a large number, and that's basically how many units that this whole thing is going to live on for. So right now it's got it set to 2000. We're making sure we're only sending positive numbers by using the max node, and this comes at the very end, and it will, if we visualize it here, we visualize it by spreading this out. What you're seeing here is this other sphere mask which comes on at the very end and starts wiping everything. If I was to change this value, so just scoot that over. If I was to change this value now, small ripple spawn duration, if I change that to 5,000 units, for example, then we're going to get an extra 2,000 units that we can move through before it starts to wipe. And so that there is just making sure that we have we are defining the window at which we can spawn our sine waves. So we add that in on top of our medium and our large ripple. And then what we do here is that we're doing a lerp. So this is allowing us to paint in the viewport, so that we can art direct where we want these ripples to affect and where not. So if there is any red vertex colors and then that value is true, then we're going to send a value of nothing. So there won't be any deformation in that in those areas. And then what we're doing over here is we have our vertex normal world space, and we're just masking out the R and the G, and just appending in a 0 for the B. Now what this means is that we are not going to be doing any transformations in the Z axis, That just worked for this effect. I mean, if you're building an effect similar to this, you may want to have something in the z-axis, but we decided for this effect that we only wanted it to be in the x and the y-axis, and so we're just multiplying that. So anything that would be in the z channel is multiplied by b, and then all of that just goes into our world position. And we've done some masking. We've done some masking here, just so that I can visualize it in the viewport. But that is the main overview of what the shader is doing. Okay, so finally we're back in the level, and we're going to turn our strength back up. And we just want to visualize why it was important to start masking out certain areas of the mesh. So you can see here we've got this problem area in the side, and this could be part of the effect if you wanted it to be. If you wanted the size of the building to pulse and rotate like this, but it wasn't necessarily something that that I wanted. So when we go down to our mesh pane and we can visualize our red channel, we can see that there's no red channel here. So if we wanted to, we could turn that off now, or we could come in and paint. And if we paint red here, we can see that actually we're going to be painting away the effect in this corner. So it would have had the illusion that the sides of the building are able to contain the ripple. Turn on our red view mode and just make sure that we get a nice paint here, and turn that off. And then now you can see that the ripple isn't giving us those problem areas in the corners anymore. So let's go and take a look at the final effect. So here is the final effect now. The final effect where we have a transition area just outside the ripple where our pivot painter is happening. Our pivot painter is also happening in the middle, in the struts and columns. And the main portion of the effect that we're seeing there, that's pushing everything out, is the ripple. So it's kind of like that, that the ripple is pushing into our pivot painter materials, and our pivot painter materials is kind of trying to keep up with this oncoming wave that's coming out. So the way that we've combined these two effects is we've just done another transition mask, and this transition mask lives outside of everything. So the large ripple sits inside of the transition area, and the transition area comes down here. And if we're using our ripples, then our pivot painter can only happen inside of this transition area which you've got here. So this is just the sphere mask with the height and world position going into there without any subtractions. Whereas over here now we have a large ripple offset, and this offset is offsetting it from the edge of our sphere mask. And then all we are doing is we're going to take our output from our vertex normal world space, and we're just going to add that into our world position down here. And so after we've done our scale and rotation, we just add in our ripples, and then that is going out to our world position offset. And it's as simple as that when we are combining the two. One other thing that I haven't mentioned is our meshes need when you're ray tracing, our meshes need to evaluate the world position. So if you take this off, you see that the things that are happening on the shader aren't affecting the lighting, so it's still being shadowed as if this building is whole. So you need to make sure that you select your mesh and you tick evaluate world position offset, and then that way everything's going to look light and shade properly. So I'm going to teach you quickly how to use a blueprint asset so that we can quickly change a bunch of variables just by drag and drop. So it's really artist friendly when you hand this tool off to a set designer or something like that. All right, see you there. Okay, so currently I'm in the Unreal for All Creators project. This is a project that will be released to the marketplace for free for you guys to delve into the shader. And I'm here to talk to you about data assets. So first off, let's explain what a data asset is. Now, for each one of these buildings, they have multiple shaders. There are two pivot buildings in here. So there's one for the outer and there's one for the inner. So there's a lot of variables that aren't going to change and don't need to be used for look dev purposes. They're just variables that would be set and forgotten about. That's quite a lot for an artist who doesn't know anything about this this setup to come in and automatically know what shaders need to go where and what textures need to be put where. So that's what a data asset is for. So you see when I open up a data asset here, it's going to have all my materials saved for the outer materials, all of them for the inner materials. It's got my meshes as well for the inside and the outside, and it's got my pivot textures. And when this is working in the system, you can just pull out any instance of this blueprint. And this, for example, is a ripple building. I could take this data asset now and put it in, and put it in here. And all of a sudden now it's just a pivot painter building. It's not a ripple building. I could take the data asset for this building here and plug it in here, and now it's got a whole new mesh, and it's just a pivot painter building. It doesn't have any ripples on it. And then I could do the exact same thing for the ripples. So now this building has a ripple effect on top of it as well. So then I guess the question now would be how do you set these up? So I think it's pretty obvious why you would use it. So the first thing that you need to know is that it's a blueprint. So you need to right click blueprint class and drop down all classes and type in a data asset, primary data asset, and then you'd call this whatever you wanted. I'm going to prefix it with DA, so for data asset, and then you can just call this building config or whatever you would like to call it. And then in here is where you will create variables. So you'll create a bunch of variables that you are going to need inside of your blueprint. I've already done it for this. I created arrays for the outer materials, inner materials, different texture assets here as well for the pivots and rotation axes. And then what that looks like inside of the blueprint is you would create a reference that is a variable to that. So here I've got building configuration. And that is just a variable type DA pivot building, but I could create one now for the one we just created, DA underscore building config. So we've got that there, and then you just make that you just make that public so that you could add it in as a variable. You can see right there. And then what's going to happen is that you're going to pull that off, and now whenever for example, when we are doing when I'm updating the pivot painter, so I just have a bunch of functions that are just updating and setting values inside of the shader. But when I want to reference things that aren't going to change, so for example, the building meshes and things like that, and textures, so the pivot textures, for example, all I need to do is just pull off from my building configuration, and I can just do get outer material pivot, for example, or get outer materials, and I can reference that inside of the blueprint. And all of those values get set. So here I'm doing it again for the inner materials. I'm getting the array that I've set that contains all of my materials, and I'm feeding it into this function that is just creating a dynamic material instances and setting the materials to the meshes. And it's a really optimized way of working through this to just be able to set your set all your variables in one place, and then just have one nice little neat container that you can just pull off and have access to all of those variables. So when you come to create the assets, you're going to right click and go to miscellaneous and data asset. We're going to find the data asset that you created, DA. We created the building config one. Select that. And then you're going to call it, DA, whatever it's going to be, building A. And then you come in here, and then you'll have access to all of your variables here, which is exactly, for the type that I created when I was creating this. Here are all the predefined variables that I had created. And then you set them in here. And then you set them once as the person who set up the tool, and then you can just send this off to your artist with the Pivot Painter blueprint, and they can just switch in and out whatever config file that they want to get the kind of building that they want. It's a really powerful tool.
Wow, that was hardcore, man. Thank you so much for putting together this webinar as well as generating the effect. Really a beautiful shot, and to get that kind of holistic approach to what your ideology behind that was super, super cool. So thank you.
No worries. Thank you for having me on.
Yeah, awesome. This is good stuff. So we had some questions come in. A bunch of people were asking about different versions of Pivot Painter. So obviously you were doing this one in 3ds Max. Yes. There's some other iterations of Pivot Painter scripts or technologies out there for other DCCs. So maybe you could expand on that a little bit.
Yeah, sure. I think that I also explored this myself. So originally when I started doing this, looking into it, I was using Houdini, and I couldn't get the effect to work properly. Their node is a little bit of a black box. It's kind of like it doesn't have many options on it.
Okay.
So I reached out to John Lindquist, who is the person at Epic that wrote Pivot Painter, and he basically said that the only one that he's written is the Max script, and so I guess there may be other Pivot Painter tools out there, but the only like Epic sanctioned one that, say, if you're following this along and you want a guarantee that it's going to work, then the only Epic sanctioned one is the one that ships with the Unreal Engine, which is the Max script written by John Lindquist.
So, right on. Very, very cool. Well, The thing that I thought was so great about it was the flexibility that it had. I mean, obviously you're a very technical artist, a technical director, but it looked like once that was packaged up, it was really pedestrian in nature. Like you could hand that off to a general artist and they would be able to replicate that effect and dial it in and work their magic with it really easily.
Yeah. I mean, when you're a technical artist, working in production, that's kind of how you want to have your tools when you hand them off. You really want to free whoever the set dress or the environment artist is that's going to be working with the tool. You really want to be able to free them to just be able to create and not have to really worry and think about what's going on underneath the hood. So that's kind of what you want to think about when you're designing something like that. Like how the end user going to be using it.
That's awesome. So talk to me a bit about the hardware that you were doing this on.
Yeah. So Epic shipped my machine to me. So I'm using a 2080 Ti. I have 128 gigs of RAM, and I have an Elixir processor. But I mean, not all of us were on our work machine. So our lead artist Saga was on his actual home machine, which again was a 2080 Ti, but he only had like 32 gigs of RAM and like a i9 consumer processor.
Right.
So you could get this shot done on a high-end consumer PC.
Nice. And I noticed that when you brought the mesh in, like when it was in Max, it was hundreds and hundreds of different individual nodes, which would obviously, those would each be a draw call if you brought that in. But I saw that you were combining that down. So even in a game context, with a lightweight effect, or maybe not a city scale, but like a more reasonable scale, you could use this in a game context because it looked like it meshed it, it combined it down on the import.
Yeah. It could definitely be used in a game setting. It only gets really expensive when you're ray tracing, because you have to evaluate the world position offset, and because the world position offset happens after the ray gets cast. In order for it to shadow and shade properly, it needs to upload a unique version of the mesh to the ray tracer every single frame. So then that's when you really have to start thinking about how complex the mesh is.
Okay.
But if you're not ray tracing, if you're doing a game as a non-ray tracing game, it runs really, really well in a game setting.
That's awesome. Yeah, it's super cool. And I mean, I guess it really is sort of like two things, right? Because you've got the draw of whatever the material is, but then you're throwing on top of it all this kind of vertex math. So you can kind of mix and match it pretty easily.
Yeah. Like so that is one thing performance wise that you need to think about, is that this effect is made to plug into existing shaders. So you're gonna have the instruction count of the actual instruction itself, but then you're gonna have whatever shader or blending of stuff that you're doing on top. But in essence, the effect is still relatively cheap, because I plugged this into parallax occlusion shaders and all that kind of stuff, and it worked perfectly fine.
That's awesome. So some other questions that there was a pretty decent thread going on in the chat there about VFX and like Unreal and its place in the industry, where it's going. When is it the industry standard? Like I don't think it's quite there yet, but I mean, maybe you could talk a bit about that, maybe some of the fellowship stuff that sort of just happened that's super, super cool.
Yeah, sure. Yeah. So yeah, I was a mentor for the fellowship scheme, and the fellowship scheme was quite special in the fact that you have to have an IMDb credit and a couple years of experience in order to be eligible. So we had loads of like industry veterans come through. They're all super talented in their field, and they were able to pick up Unreal and output some really impressive short films in a matter of 4 weeks.
Wow.
They were also creating their short films while learning Unreal. So it is super intense, because they start in week 1 actually making something, and they don't actually know how to use the Unreal Engine yet, and they keep getting drip fed in information. But it's really quick to kind of pick up and kind of get started once you have the right education tools.
Yeah, and I've actually watched a fair bit of the videos that have come out from the first round of the fellowship participants, and they're really ridiculously good. Like, you're like, I can't believe this. I think you'll probably see a lot of people starting to drop these on LinkedIn, and I know that we'll be continuing to kind of start to push them out to show what was achieved. It was pretty amazing. And the thing that's kind of interesting about it is, like, all those people that got into the fellowship program, like, they're going to be out there in their studios or in their professional workplace, and now it's like they've got that seed planted, right? Like, once you start using this to do traditional effects, and you're doing them with the pace that the engine gives you, it's pretty addictive, right? Like, I mean, it's pretty awesome.
It really is. It frees the iterative look development cycle up. So when you do start getting into Unreal, and you really start to focusing on actually look deving an asset or a shot, it really frees you up, because there's almost no cost to trying something new. So you can swing some lights around and move assets and tweak shaders, and the feedback is like immediate. You don't need to worry about having to, if I do this, then I've lost my lighting setup, and I'm going to have to render it for half an hour to see the result. It's like super responsive, and I think that's really what they gain from it. It's just that immediate feedback in the viewport. And with UE5 and Lumen coming in as well, I think that we're going to start seeing the convergence of VFX in real time.
Yeah, the future's very bright with that stuff. So another not necessarily related, but kind of related. There was a couple questions about virtual production and like I keep seeing this in camera VFX stuff like The Mandalorian and I mean so many amazing groundbreaking projects that are being done with that. What's the minimum cost of entry? So I mean, obviously LED walls are ridiculous. They're going to be popping up everywhere. I mean, you basically work at one or gun like the London lab, the Epic Unreal lab that's in London. Maybe you could talk a bit about that.
So in the London Innovation Lab, we are building we're building an LED stage in the middle of central London, and the whole aim of that stage is to be able to bring people in and teach them how to do LED walls correctly. So we've got ARRI cameras, we've got motion capture, we've got lights, the everything is going in. And so then to do the LED walls right, there is quite a big entry cost in terms of personnel and equipment, and we're figuring it out while we're installing it. So like having ceilings, having enough wraparound, actual set dressing like physical set dressing that kind of extends what you've got in the back, because it really does another step for immersion, but. But in terms of entry costs, we're talking like LED panels that are about 50 centimeters by 50 centimeters. They cost about $1,000 per segment, and if you're filling up a wall of that, the cost soar.
It can get cost prohibitive for someone to buy, but then there's going to be all these LED stages that are being. It's like do you own a soundstage or do you rent a soundstage to go do your shot, kind of?
Yeah.
And I think LED walls are sort of falling in that. And then from a hobbyist perspective, I mean, you see like the stuff that like Matt Workman's doing. If you guys don't know Matt Workman, go on LinkedIn, Google him. He's doing some pretty interesting things, and it's very DIY-ish. I mean, he obviously has some pretty cool toys that he's getting, but he's experimented and he's doing, some pretty funky things that are relatively accessible, I think. So there's going to be a variety of different entry points for people where they can sort of play around with this from the very high end to the very low end, which I think is super, super cool. So that pretty much brings us, we're a little bit over on time here, kind of at the top of the hour. I'd like to thank everybody for watching it. I know this one was a bit deeper than most of the webinars that we do, but I think that I walked away from it with a really firm understanding of the concepts behind this and the logic and what you were thinking when you were creating these effects. So thank you so much for taking the time to do that. And keep in mind that we did include a very simplified version of the project. The Unreal for All creators assets are going to be packaged up and available in the marketplace later on. So we're still working through getting them packaged up, but to get you guys started, Malachi was kind enough to throw together. I hit him last night. I was like, dude, we need to get a sample project, and he made it happen for us. So thank you so much for working on that last night. And that's in the link for you guys. So that's basically it. Thanks again. Thank you, Malachi. I'll let you close it out.
Thank you for tuning into the webinar. I hope that you all got something from it, and hopefully it's not too long before I jump on and show you something new.
Awesome. Well, we'll have you back soon, hopefully. Cheers, everybody.
Cheers.